this is Mr. Bornheimer, and this is a quick 5-minute video on the atom. First of all, you're looking at an atom, and you'll notice that there's this blue fuzzy area. We call that kind of like the area of the atom. Okay, atoms are really spherical objects, kind of like a ping pong ball. Okay, and that black circle is kind of what we call its boundary. See, the edge around an atom is kind of fuzzy. We kind of know where it is, but it's not like a hard line, like a ping pong ball. All right, so here we have this atom, and today we're really going to focus on this central part of the atom, which we call the nucleus. Okay, so we're going to zoom way in here, and we're going to zoom way in, and this is where the nucleus is. It's at the very center of the atom. It's a small, dense region of mass. So, in the nucleus are these small spherical particles, kind of like mini versions of the ping pong ball. So if I had this was my atom, in the very center would be tiny little spheres. This particular sphere has a unique property, and that is that it has a charge. Okay, a charge is something like a battery. You have positive and negative terminals of a battery. Okay, well, that's the same here. This particular particle has a positive charge. We call this particle a proton. Proton, positive, proton, positive. So, let's write that. Next to protons in the nucleus are other types, or another type of particle. This particular particle, a lot like a proton, except that it has no charge. Okay, it has zero charge. We call this particle a neutron. Neutrons have zero charge. I'm going to put a little zero right here in the center. And I'm going to put a line through the center so you know that it's a zero charge. Okay, so this particular particle is there, and what it does is it helps stabilize the nucleus. So we have protons, and we have neutrons. And every atom is made up of these particles. There are these particles in the center and what we call the nucleus. Some atoms have just a few particles. Some atoms have lots and lots, hundreds of these particles. Just depends on the atom. Okay. Now, they form this little region. So we could draw a few extra of these. We could draw a couple more. So we could draw another proton. And we could draw another proton over here. And we could draw a couple more neutrons. And we'll draw one more proton. Draw it right down here. One thing we do know about the nucleus is that it is where the atom's identity is formed. Okay? The protons are kind of like identifiers. They determine the type of atom we're working with. So protons play an important role in that they determine who or what the atom becomes. Neutrons help with its stability. There are certain atoms that have to have a certain number of neutrons to be stable, and we'll talk more about that relationship in a little bit. So this nucleus is held together, and it's held together by kind of like a subatomic glue. We call this glue a type of force. This force, which interacts inside all of these particles between protons and neutrons, is called the strong nuclear force. And it is kind of like the glue that holds the whole entire nucleus together. So just to recap really quickly, we have these particles in a nucleus, which is the central dense region of an atom. These particles are called protons and neutrons. Protons are positive, neutrons are neutral, and it's all held together by the strong nuclear force.